As you know, we discussed chat prompt template class of Langchain. Also, we have developed web application using Streamlit. Let's run this web application. So for that, we have to write Streamlit run and our file name demo_no_memory.py, and this is our web app. Let's write my name is Priyang. Let's press enter. You can see, hello Priyang, it's nice to meet you. How can I assist you today? Now let's remove this and let's ask what is my name. Let's press enter. You can see, I am sorry, but I don't know your name. If you would like to share it or ask me anything else, feel free. See, it forget my name. Let's try explain AI. Let's press enter. You can see nice explanation about AI with two types, narrow AI and general AI. Now let's write summarize it in 3 points. Let's press enter and you can see, of course, please provide the content you would like to summarize. I will create a 3-point summary for you. Can you see? It cannot summarize because it does not remember what it explained in the previous message. This happens because this chat prompt template class of Langchain only formats the prompt like this. It defines the system message and the human message, but it does not store any previous user or assistant messages. Every time we send a new input, the conversation starts fresh. That you can see, there is no memory, so nothing is carried forward. So now we are going to add a memory component to our chatbot so it can actually remember our conversation, meaning it can remember our history and reply accordingly. So let's first discuss our flow. First, we will create a console-based app from scratch. That means we will interact with our chatbot through terminal. Let me show you this. Let's run this demo that we are going to implement from scratch. You can see, as I said, we will create a console-based app from scratch. It looks like this. That means we will interact with our chatbot through the terminal. Let's run. Let's write my name is Priyang. Let's press enter. You can see the response from our LLM. Now let's ask what is my name. Again, you can see, I'm sorry, no memory, right? So we will implement first this application, console-based application from scratch. Let's press exit. Done. Clear this. After that, we will add memory to our console-based chatbot. After that, we will add memory to our console-based chatbot. This will allow the chatbot to remember previous messages. Means now our chatbot can remember history and reply accordingly. Let me show this. Let's run Python and the second demo, memory_console 2.py, that we are going to implement from scratch. Just I am showing how it will work. Let's tell my name is Priyang. You can see the message as a response from LLM. Now again we ask what is my name, and you can see your name is Priyang. How can I help you today? Again let's tell explain AI. You can see explain AI in very nice manner. Now let's ask summarize this in 3 points. Now you can see, great. You can see now our chatbot can remember history and reply accordingly like ChatGPT. We are going to implement this from scratch. Exit from this. Let's clear this. And finally, we will create a Streamlit application with memory. For that, we need to use a different Langchain memory class designed specifically for Streamlit. Let me show you how it looks. Let's run this. Streamlit base, so we have to run like this. Streamlit test.py, and this is our final chatbot. Explain AI. You can see nice explanation of AI. Now the main part. Summarize it in 3 points. Let's press enter, and you can see now it can remember our history and reply accordingly. Can you see this? We are going to implement this from scratch. This is our final goal. Now let's get started. As I said, first we will create a console-based app from scratch. After that, we'll create Streamlit-based web application like this. So let's get started. Now first, let's close all these files and let's create new file, chatbot_console.py. So let's import required libraries. From .env, we have to import load_.env. From Langchain_OpenAI, we have to import chat OpenAI. From Langchain.prompts, let's import chat prompt template class. And let's load our environment variables. So we can use our API key provided by OpenAI. Now to save our recording time, let's copy this chat prompt template, paste it over here. So here is our placeholder and this is our model, right? We are going to use GPT-4o mini from OpenAI. Let's save this. Now the main thing. Here we are going to use simple chain concept. Don't you worry. We will discuss this in very much detail later. But just I want to introduce chain concept. For that, chat underscore prompt, pipe symbol and LLM. And let's assign it to one variable chain. Right? This is a very simple chain. So this chain concept help us make our code cleaner that you can see here. Here we are simply connecting the prompt and the model in one line using this pipe symbol. This means the prompt will format the messages. The formatted messages will be automatically go to the model. So as you can see here in our demo underscore no memory code, we have used invoke 2 times. First on prompt and second on LLM, right? We don't have to call invoke twice anymore like this. Because now we are using chain of Langchain. So now we just have to invoke the chain because the chain already connects the prompt and the model together. Think of it like joining 2 pipes. The first pipe means prompt, prepare a message like this. And the second pipe, the model produces the answer. That's all. As simple as that, right? Output of this become the input of this. As simple as that. So this pipe symbol tells Langchain whatever the prompt creates, send it directly to the model. That's all. This makes the code much cleaner and easy to read, right? Okay. As I said, we will discuss chain concepts in very much detail later. Now we have to add this infinite loop because currently we are developing console-based application. So our chatbot can accept multiple messages as I showed you earlier during demo. So the loop will keep running until the user types quit, exit or stop. Let me show you this. First, take input from the user and you. And let's create one variable user underscore input is equal to input. If user underscore input, if it is upper, convert it into lower and let's create one Python list with 3 items, exit, quit or stop. The loop will keep running until the user types quit, exit or stop. This gives us a real chat experience like ChatGPT, right? Where the user can continue sending messages one after another. Let's print one nice message if user write, exit, quit or stop. Chat ended. And let's break this loop. Now the chain. Like this, chain dot invoke. Here our placeholder user underscore message. This placeholder user input, this one input, right? And let's assign it to one variable response is equal to this. As you can see here we are invoking just chain because now it is connected with prompt and LLM both. But here you can see in our previous code we invoked that prompt template and also LLM that you can see, right? Thanks to chain. And let's print response dot content. Done. Let's try to execute our code. Python chatbot underscore console dot py. You can see again same explain AI. So I'm waiting for the reply from GPT-4o mini. Great. Now again let's ask summarize in 3 points. But currently we have not added the concept of memory. So the output like this, it can't summarize because now our chatbot can't remember our history that we have to add explicitly that we are going to do next. Let's exit this. Done and clear. You can see that we have entered exit and chat is ended. Great. Right? Now you can see our code is working fine. Now let's add memory component to our chatbot so it can remember conversation like ChatGPT. Means it can remember history so it can answer accordingly, right? Now to add memory component to our chatbot, we have to import some libraries. So first here from Langchain.prompts with chat prompt template class, we have to import this messages placeholder from Langchain underscore community dot chat underscore message underscore histories. We have to import chat message history class. Also from Langchain underscore core dot runables dot history, we have to import runnable with message history class. This is wrapper class. Done. So we have imported required libraries. Now let's create instance of this class, chat message history class, and let's assign it to one variable string is equal to this statement. So please remember, this creates a small in RAM random access memory storage where all past messages will be kept. Now next important step, here messages placeholder with variable underscore name. Let's give string and comma. Let's save this. So this tells the prompt where these past chats should be inserted when preparing the full message for the model, right? Now the main part. Here we have to create this wrapper class, which is wrapper around our chain. So here we are passing our chain. Next, get underscore session underscore history. For that we have to use lambda, and here I am creating anonymous function using lambda, and here history. So here our wrapper class around our chain, and this tells the wrapper which memory to use. The wrapper fetches the stored messages from RAM through this history object. So this tells the wrapper which memory to use. The wrapper fetches the stored messages from RAM through this history object. Next, history underscore messages underscore key. Again, here history. So this tells the wrapper where to insert those past messages in the prompt using this. It matches the variable used here in the prompt, history. So that's why here is also history. And next, input underscore messages underscore key, our placeholder user underscore messages, this one. This tells the wrapper where to find the new user message so it can add it along with the history, right? Our placeholder, which is the message entered by the user, new message. Done. Let's format this. So again, I am repeating. This tells the wrapper which memory to use. The wrapper fetches the stored messages from RAM through this history object. This tells the wrapper where to insert those past messages in the prompt. It matches the variable used here with messages placeholder. And this tells the wrapper where to find the new user message so it can add it along with the history, right? Which must match with this placeholder. Now done. Let's assign it to one variable. Runnable is equal to this statement. Let's save this. Now our final step. In place of invoking this chain, now we have to invoke our wrapper class, this runnable, right? And also here we require this parameter configurable, and here we have to pass session ID. Let's give demo. You can give any other name as well. I think done, right? So here we have imported required libraries. Here we have added messages placeholder, create the instance of this class, chat message history class, and our wrapper class. And finally we invoke this wrapper class and added this session ID. So here we are only providing this session ID. So it remember the chat as long as we keep using this session ID demo. If we wanted to handle multiple users or different chat windows like ChatGPT does, we would simply generate different session IDs for each user or chat windows here. But currently we are handling for one session ID, right? So it remember the chat as long as we keep using this session ID, but we can handle multiple users with multiple chat windows as well, right? I think all done. Now let's try to run our chatbot with memory. Let's press enter. Done. Let's write my name is Priyank. Here it is showing this. Oh, sorry. User message. Let's save this. First, we have to exit. Let's clear and let's run one more time. Again, my name is Priyank. As I said, we are interested in our next message. Let's ask, what is my name? Great. Your name is Priyank. How can I help you today, Priyank? Great. Now it can remember our conversation, right? Let's also display history so you can understand it in better way. So here, print and history dot messages. Save this. Again, let's exit this. Let's clear this and let's run one more time. Again, my name is Priyank. Can you see human message that I entered and response from our model? Human message and AI message. Now let's confirm what is my name. Now you can see history size is bigger because now it is handling 4 messages. User AI, right? For more visibility, because here we can't read it properly, let's use list comprehension. Just we are going to display user and AI messages, nothing else. We are going to remove other extra informations. Let's clear this. Let's back to our code. Let's comment this. And here in print, I'm going to use list comprehension. 4M means message in history dot messages. Let's print M dot content only. We are interested in content. Let's save this. Now let's run this. Here again, my name is Priyank. Now you can see this list with user message means human message and AI message. Let's ask, what is my name? Can you see this list? Please remember, each time we send a message, all previous messages stored in history are passed to the model along with our new message, because the model sees the full conversation like this. It remembers details and answers correctly, that you can see, right? Again, let's ask, explain AI. You can see with all the messages are kept inside history, and this is our explanation for AI. Summarize in 3 points, and here are our 3 points that you can see, right? So this list simply shows everything that was sent to the model in order, which is why the chat stays consistent, right? Let's exit this. Let's clear this. We are not interested in history. We are interested in response. So let's comment this. Let's save this and let's run one more time. Explain Langchain. You can see explain Langchain and summarize in 2 points. You can see here I am not giving any subject, just summarize in 2 points. To give the answer of this, it required the knowledge of previous answer. Let's press enter. Great. You can see now our chatbot has memory in the console, so it can remember past messages and use them as context, that you can see here, right? Let's exit this. So you can see our console based chatbot is working fine with memory. Now let's create a GUI for our chatbot using Streamlit. We are going to create GUI using Streamlit, so we have to use a different memory class so that our Streamlit session can actually remember the conversation. Means our Streamlit session can actually remember the history, so it can answer accordingly. In the console version, in this version, we used this class, chat message history class, which stores everything in RAM, in random access memory. But in Streamlit, the app refreshes on every interaction, so RAM alone is not enough. That's why we have to use different class, Streamlit chat message history class, which is designed specifically for Streamlit. So now let me show you the Streamlit version of our chatbot with memory. So first, just we have to replace this class with Streamlit chat message history class, and this class is again available from Langchain _community .chat _message _histories. We are importing this class, Streamlit chat message history class, and let's copy this class and we have to replace here as well. Let's save this. We have to keep this as it is. Also this wrapper class and other things that we have mentioned here, all are remaining as it is. No need to change anything, right? It's done. Now let's create GUI. So as you know, for that we are going to use Streamlit. So let's import Streamlit as ST. Let's write title for our web app, my chat bot. Done. Now here we not require this infinite loop. Everything will be handled by Streamlit. So in place of this Python input, now for our web app, we have to write st.text_input, and let's check if user_input available, then only execute this. Also, we not require this. This will be handled by Streamlit. Done. And in place of printing response on the console, we have to print on our web app. So for that, we have to use st.write. That will write our response from LLM on our web app. Done. So just we have imported this class, right? Which is specially designed for Streamlit. It stores all messages inside Streamlit's session state. So the conversation doesn't disappear on every run, right? That's all. As simple as that. I think all done. Now let's execute our web app. We have created using Streamlit. So we have to run like this: Streamlit run and chatbot_console.py. Let's press enter. Okay. Again, let's ask what is AI, and you can see response from our LLM GPT-4o mini. Now we are interested in this. Summarize it in 3 points. Let's press enter, and great. You can see now it can remember our conversation and previous message history. So it can answer accordingly, that you can see, right? As I said, each time we send a message, all previous messages stored in history are passed to the model along with our new message, because the model sees the full conversation, full history. It remembers details that you can see here and answers correctly, right? Also, let's print history here so you can understand it better. So now press Ctrl C to stop this. Let's clear this. And here, let's print history. Let's write with st.write and only this history. Let's create different sections. So write history. So it looks better. Save it. Then again, let's run our chatbot. To keep it simple, let's write my name is Priyank. Let's press enter. Can you see the history? Human message and AI message. Now let's remove this and let's ask what is my name. Let's press enter. Now you can see the history. As I said, each time we send a message, all previous messages stored in history are passed to the model along with our new message that you can see here. Because the model sees the full conversation, means this history, it remembers the details and answers correctly, that you can see here. Again, let's try explain AI. Let's press enter just to show you the history. You can see here. And you can see the history as well. It remembers everything, our full conversation, that you can see, right? Again, if I ask summarize it in 3 points, you can see the complete history. So our chatbot is working fine, but we are not interested in history. Just I showed you for teaching learning purpose, but we are interested in our output. So let's press Ctrl C. Let's clear this and let's comment this out. We are interested in response only. So let's save this file and let's run our web app. Again, let's ask what is Langchain. You can see the nice explanation about Langchain. And let's tell summarize it in 3 points. Great. You can see our chatbot is working fine. So this way we can add memory component to our chatbot using Langchain. Now let's move on. Let's discuss chain concept of Langchain in detail.